Hello and welcome to another Parallax Quick Byte. Today we're going to have a look at the new HD audio set for the P2 microcontroller. Here they are on the right hand side, two boards. The top one is a 4-channel ADC, 32-bit and up to 192K sampling rate. The bottom board is a 2-channel DAC with the two large silver caps on it. So they both have stereo jacks, left and right. Both jacks have header pads next to them if you wanted to solder on standard 0.1 inch pitch headers and use those instead of the jacks. The DAC board I think is self-explanatory. It's you can plug in headphones or some sort of line out into your audio equipment. The ADC has the two jacks there, so two stereo inputs. The bottom one is line level only. The top one, you can configure it in code. By default, it's also line level, so two line inputs if you like. But you can configure it in code to work with digital microphones or our old school analog microphones, and you can apply a phantom power pull up to it. And that's also configurable on both left and right channels simultaneously, or just the left or just the right. So you could use, two different mono microphones plugged into that top jack and configure them differently. And so quite versatile. So let's just have a look at how that all plugs together and the other parts we've used. So I've used the mini breakout board here, the P2 mini breakout board. You could use the larger breadboard, of course. I'll list all these parts in the QuickByte anyway. I've used the standard P2 Edge module. I wanted the demo to work on that, but it'll also work on the RAM edition as well. And I'm sure later in the forum some smart guys will add some code to use the RAM edition as a buffer for the audio and to do all sorts of interesting samples because you would be able to with 32 meg on the other P2 Edge module, but we'll just get started with the basics using the standard P2 Edge module. I've got the ADC and the DAC on the right hand side obviously, and I've added a control button board, which is another P2 add-on on the left, just to give us some 4 buttons for looping and volume adjustments in the demo. There's a prop plug there for programming the P2 Edge module and a DC to USB barrel jack cable for providing 5 volts from my USB hub. And that's all there is really to it. I've plugged some headphones into the DAC so I could listen to it. I've got a line-in source coming from my computer. That's what that box at the top there is. It's just a sound output interface from my computer. But you could use an MP3 player or a mobile phone sound jack output or whatever you wanted, or even a lapel microphone or whatever, plug it in there as your audio source. Ignore that VHO 360 speaker. I was going to do a little delay demo, but it didn't quite work out with the recording setup here, so we'll just in the end I just ran a cable into my computer so you could hear the sound. So yeah, so that's the hardware setup. Let's pull up the code. So this is the first file you'll be able to download from the QuickByte. There'll be another demo for just analog DAC. I might have that as a separate QuickByte, or in this one it will turn out. But anyway, this is the HD audio ADC to DAC demo. Set up your base pins as always. It's the same story. Open up the code, check your base pins are right. If you've plugged your hardware together the same as in the video, then you'll be good to go with the default settings. The buffer size is just how long the delay is going to be, but you could just leave that alone for now. And that's it. Go down to main, choose which demo you want to hear. Maybe we'll listen to that one first. Demo line in 0 will just play the line in source directly out of the DAC headphone jack immediately. Demo line in and introducing a buffer size will delay the output by the value of that buffer size, or more precisely by that number of samples. So if you put 10,000 there, it would delay the output by 10,000 samples. Demo mic in is almost the same as line in, except it will do the same from the microphone jack. And then we've got a demo with looping effects. Oh, that is enabled, so maybe I just get rid of that one and just play the loop effects. Now, just one thing to draw your attention to the demo mic in. As I said, the guts of it is down here, which is just read left and right channels. In this case, input from the microphone instead of input from the line. Optionally do some jiggery pokery on the sound, so you might add some echo, some delay, some flanging, or whatever you might fancy, and then write the samples. Once you've finished, write the sample back out to the DAC, and then it will play it through your headphones. So really it's as simple as that, and in its simplest form you would read the samples in and write them out, and it's only optional if you want to do some effects here. One thing you could do, for example, is to read the samples from the microphone channel, but also then read the samples from the line channel together, and then possibly mix them together, maybe 50-50 or whatever, and then output the mixed signal to the DAC. So yeah, lots of interesting things you could do there. And as I say, that's generally the same as you'll see above for the line input, almost exactly the same code, except we just changed the source from input to line. But just to draw your attention to these extra 3 commands that appear in the microphone demo, and they are activating phantom power and adjusting the mic sensitivity. So the standard gain for the mic is 0, which is a value of 128, but you can change that sensitivity if you need to, and you can change it by channel, so by left or right together, or just left or just right. So independently you can adjust the sensitivity for each of the left and right channels. You can set the power, that's common, so that will be for both left and right. You can set the voltage of the phantom power, so 1800 millivolts, 2,500, 2,800, so it's essentially 2.8 volts, 2.5 volts, 1.8 volts, and I think there's a 3 volt option hidden over there. Yep, the 3 volts as well. So you can set your microphone pull up, and then you can turn on or off. You could change that to off if you didn't want any phantom power, and with it off, essentially it's a line input. Yeah, you can turn on phantom power if you want to, and again that could be just left, just right, or LR for both channels. So as I say, you could potentially plug in 2 microphones there, and have them configured differently if you wanted to. Yeah, I think that's all really. And then the code is here, and again this is just to kind of get you going with the basics of how to use the driver and to give you something that's working off the bat. The ADC itself has lots of other filtering and special effect functions, voice detection, and all sorts of interesting things that we've not implemented here, but we just wanted to get you going with the basics. So we've got the start routine. You can set up the impedance and the drive output of the DAC, and so you could pass in with your setup. When you start the driver, you can tell it if you want to have any of these 4 options for drive strength. Almost 1K there, 990 ohms, 600, 124 ohms or 75 ohms, and they've got different voltage peak-to-peak settings as well. So you can find something that suits your environment. Many headphones use 31 ohms, so what we do there is choose the 124, and then we gang together in parallel 4 smart pins, and so therefore we divide that by 4, so we get that down to 31 ohms. I probably skipped a step there, but anyway, the basic start, I'll cover it now. So the basic start command, you just give it your base pins of the ADC and the DAC, and it will make a decision for you that, okay, by default I'm going to drive 31 ohm headphones, so therefore it selects the drive impedance at 124 ohms, and it selects 4 as the impedance divider. So what it does is divides that impedance 124 by 4. Behind the scenes, what it's doing is enabling 4 smart pins per channel, so therefore 4 parallel 124 ohm smart pins equals 31 ohms. You could change that, and you could just have 1, and then you'd be driving a 124 ohm output directly. You could have 2, you could have 3, or you could have 4. So you can do the math to set up the your output as you need. And that's why there's a second command called *x, which enables you to pass in those values. And as I say, you can look up here to see a description of the options. There, if you wanted to have a 1K output, there you go. If you wanted 75 ohms, there you go. If you wanted, half of 75, so, you could just put 75 and divider of 2. So very flexible. So that's that really. The rest of it, read through. I think it's quite self-explanatory, and at the bottom there's the PASM code. If you are getting into PASM, the PASM code might well be worth looking into, because I think there's a couple of really interesting techniques in there. But just to skip through, here's the code. We start just by listing the list of parameters that are available to us when the code starts, and then we read some of them in. It's all well defined here. We create some pin fields, we create some shortcut aliases, which again I think it might be some useful techniques to look at how to do certain things. We configure some smart pins, we create events, we do some weighting and if nots and all sorts of things. So yeah, there's some useful sort of techniques in there. And then ultimately the main loop function, where we wait for data, read it in, process it, write it out, loop, loop, loop. Yeah, so there you go. So let's go back to the demo. Let's see. So we're going to run the demo with loop effects. Why not? We do have the button board set up. So excuse me, I will just enable the debug view actually, because it might be quite nice to see that going on. There we go. So the debug output tells us all sorts of things that's going on, and yes, okay, we could do with some music now, I reckon. Let's see if we can play some music through. There we go. Okay, so what we can do is, yeah, let's turn up the gain a little bit. Hopefully we can configure one of these pins to do the gain. Playing it backwards. Okay, obviously I'm not going to get any awards for being DJ of the month here, but okay, well. Alright, I'll give up. But you get hopefully you get the point there, that the digital effects you can easily add loops, echoes and whatnot, and you might just want to do it a bit better than that. So let's just turn that down a moment, and yeah, so that's basically how to use to get started with the new audio set. So yeah, download the code, plug everything together like that, press go, plug in your audio source and your headphones, and you'll be able to see what's going on, and we'll have it published at our quick Byte page soon. And of course you can ask any questions you need anytime at the forums or through the Quick Bytes chat. And just to draw your attention to one new feature that has appeared at the Quick Bytes page, there's now a new menu or index that's been added, and you can see it. I'm just pointing to it with the mouse. I'm not sure if that shows on screen, so it's flashing blue and red, but Quick Bytes index. It's a bit of a work in process, but we're going to add some new tags here and try to improve on it. But you can already see that you can now sort by categories and find Quick Bytes that you're interested in, and we're going to expand the number of tags and make that easier to sort through as we add more content. Yeah, so I hope that helps, and I hope you enjoy investigating and playing with the new HD audio set.